Greetings, young ones. Today we're going to finish talking about the truth table, that force which surrounds and penetrates all of propositional logic. It binds and sustains us. It makes everything we do knowable, and it checks all of our validity. Well, maybe it just gives us a nice way to check the validity of arguments if the arguments aren't too big. So today, this is Professor Dan here, by the way. Today we're going to do our last logic video of the semester. I will pause 10 seconds for you to weep a little bit and then wipe your tears. Okay, pull yourself together so we can get through this. So today we're going to learn how to use a truth table to check the validity of an argument. No matter what argument I make in propositional logic, and I can take any deductive argument and turn it into propositional logic, I can use a truth table to check its validity. Okay? And I do that by just constructing a great big truth table and looking to see if there is a row of that truth table where all of the premises turn out to be true and the conclusion is false. So if you think all the way back to the beginning of the semester, those many months and years ago before the dark times, we said that validity depends on whether or not it is possible for all the premises to be true and the conclusion to be false. And when we're dealing with propositional logic, we have nice letters which don't necessarily mean anything, so we can use a truth table to figure out every possible combination without having to know whether or not any specific thing is true or false. So let's take that famous cat argument that we had at the beginning of the semester, and we'll use that to finish things off. I'm not going to write the cat argument out here in a propositional form. I'm going to go ahead and symbolize it, and I'm going to say, if something is a cat, then it has a small head. If something has a small head, then it is stupid. Therefore, if something is a cat, then it is stupid. And I'm going to use green for my operators, C then H, H then T, C then T. Now I have the famous cat argument written in propositional form. How exciting! I'm going to use slashes to separate the premises from each other. There's two premises. If something's a cat, then it has a small head. And if something has a small head, then it's stupid. And then I have the conclusion to the famous cat argument, as everybody knows by now. If something's a cat, then it's stupid. And I'm going to use two slashes to communicate that this is, in fact, the conclusion. So now how can I test this wonderful argument for validity, you ask? How can I use a truth table to determine this if I don't know anything about the famous cat argument, or if I just came in at this point in the video, or if I started the video and then I got up to get a snack and I came back and I saw that the video had progressed, and I thought about rewinding it, but then I thought, nah, Professor Dan was probably just rambling on and dropping silly special effects in and doing other assorted nonsense that he likes to do because he thinks it makes it cute and endearing, and it's really just annoying. Why doesn't he just get to the point? Anyway, so maybe you don't recall what C and H and T meant. Well, it doesn't actually matter, right? It doesn't actually matter because I can just start doing a truth table. Because I have 1, 2, 3 letters, I'm going to have 8 rows going across, and I do my initial truth values in exactly the same way as I did before. But you see here I have H is the consequent of the first conditional premise, but it's the antecedent of the second. And so again, I'm going to go true, true, false, false. And then when I get to T, I alternate and then I'm done. But when I get to the conclusion, I'm using the same combinations. Okay, I'm using the same combinations going down the whole way. And now that I've done this, why, I can just solve these conditionals, and then I will be able to tell by looking across each row whether or not this argument is in fact valid. So let me go ahead and solve each one of these conditionals. My first one, C then H, has a true value in every row except rows 3 and 4, where I have a true antecedent and a false consequent. And it's kind of similar here, but it's not quite the same. Here I have a false in the second row, and I have a false in the sixth row. But I also solve my conclusion. So now that I've done this, I can look across each and every row and see if I have even one single row where all the premises are true, that is, all the truth values under these conditionals right here, where all of these are true, but under this column right here, under this conditional, it's false. All the premises have to be true and the conclusion has to be false for the argument to be invalid. And if I cannot find any such row, then the argument turns out to be valid. So let's go ahead and look. Ooh, I think a cloud just went over the sun there. So, my first row, I see true, true, true. So therefore, this row checks out. And I'm going to go ahead and I'm going to use red as my checkoff color. And I'm going to say, okay, this row checks out fine. Here, I have a true premise and the false premise. Now, in order for something to be invalid, both the premises have to be true. In this case, I have a false premise. So if I have a row and I have a false premise, then I have a nice little way for me to remember that I don't have to keep going in this row. Once I get an F in a row of premises, then I don't worry about that row no more. So this one checks out. I get down to my next one, C, false premise, so I don't have to worry about that row no more. False premise, don't have to worry about that row no more. I'm halfway through, and I have not found any line where all the premises are true and the conclusion is false. But now as I look down the rest of my lines, I notice, wait a minute, on all the rest of these lines, the conclusion is true. But to be invalid, all the premises have to be false, and the conclusion has to be true. So, I'm sorry, all the premises, I got that all backwards. Here, rewind. In order for it to be invalid, all the premises have to be true, and the conclusion has to be false. So, if the conclusion is true, well, there's nothing more to do. And so, I check all of those rows off. So since there's no row where all the premises are true and the conclusion is false, I know that this argument is valid. And so now we have seen throughout the entire semester that the famous cat argument is valid no matter what form of logic you use, and that's why cats are stupid. Let's do something a little bit more practical and fun. Because you might be wondering to yourself, gee, Professor Dan, when would something like this ever come up in the real world, right? When would something like this ever come up in real life where I would have to be able to say to somebody, look, that's an invalid argument that you're making. Well, let's say one day, once we're all allowed to leave our homes and so forth again, one day you find yourself on a jury for a murder trial. Dun, dun, dun. And you're in the jury room, and somebody says, well, if, let's say the person who's being charged with murder is named Mary, and somebody says, well, if Mary's guilty, then she killed John. And if she's guilty, then she should spend life in prison. Well, she did in fact kill John, and therefore she should spend life in prison. That's the argument that you are presenting. Well, if we write that argument out, it might look something like this. If she's guilty, then she killed him. If she's guilty, then she should spend life in prison. She killed him, and therefore life in prison. Right? So I've got my slashes. I'll use green, as I've been doing, for my operators. And now I have an argument with three premises, right? If G, then K. If G, then L, K. And then L is the conclusion. And L is life in prison. Now, let's say that we really don't know of anything at first. Right? Let's say we don't even really know anything at first. We're just going to go through all the possibilities to see if this is even a valid argument in the first place. And so we fill out our truth table, much as we did before. I got 3 letters, so I need 8 rows. I got G here and I got G here, so I'm going to use what I used for the first one. But now I have L, and so that gets the alternating. And then K is the same as this K. And this L is the same as this L. All right. Now, in this case, I don't have to do anything in my conclusion because my conclusion is just one simple proposition. In this case, that John should serve life in prison. I don't have to do anything here. I don't have to do anything with this premise right here. He killed him. Or I'm sorry, not John, Mary. Mary's going to jail. My bad. That Mary should serve life in prison because Mary did, in fact, kill John. That's what this premise here says. So let me do these ones. These 2 conditionals. So remember that a conditional is only false if the antecedent is true and the consequent is false. Same thing over here. And now I'm going to compare that column, this column, and this column. And I'm going to look and see, do I have a row going across where all the premises are true, but the conclusion is false? And if I have that row, even just one row, then the whole argument is invalid, no matter what the truth values of any particular premise or proposition happen to be. So I'm going to remember my clever little sayings from before, and using red as my color to check these things off, I'm going to notice that I have a true conclusion here, and here, and here, and here. So I'm just going to go ahead and I'm going to check those off. Because if a conclusion is true, if a row of the conclusion is true, then there's nothing more to do. So now I have to look at this row, this row, this row, and this row to figure out if it is the case that this argument is invalid. So let me start with the second row here. I have a true premise. Oh, and now I have a false premise. And as soon as I have even one false premise, then that row is done. Because if a premise in a row is false, then I don't worry about that row no more. This one, all the premises are false, so I can check that one off. Here I have a true premise. Here I have a true premise, that's 2, but there's 3 premises. Here I have a true premise. All the premises are true. And the conclusion is false. And so I circle that row, and I note that this whole argument here is invalid. And so, lost the marker. I say invalid row 6. Doesn't matter how many rows have all true premises and a false conclusion. Just one is enough to make it invalid. Make sure I get my marker here. All right then. So I can take any propositional argument that I want, and I can draw a truth table to test its validity. Now, you might be wondering, well, wait a minute. Didn't you say in the last video about truth tables that the number of rows you have is equal to the number of letters you have to the power of 2? So we have 1, 2, 3 letters. That means we have 2 to the 3rd power, which is 8 rows. Well, what if we had an argument with 4 letters? Well, then we would have 16 rows going down. You might also be thinking to yourself, well, gee, wait a minute, Professor Dan. Right here we have 1, 2, 3 premises with 1, 2, 3, 4, 5 letter columns and 2 operators. So that's 1, 2, 3, 4, 5, 6, 7 plus a 1 column conclusion. So that's 8 going across. Well, what if we had more premises and more operators? Well, what might happen then? Well, interestingly, there's no limit, right? There's no limit to how big a truth table we could draw. So consider this argument right here. My first premise is going to be not H, then not T, then not R. So we got a T, and I got an R. Let me do my and of course, blue is the color of my parentheses. My second premise is H or E then F. Oops, that's the wrong color. I didn't mean to mess up those of you who are visual learners. My third premise is not T or E. See, I'm already starting to run out of room here. Trying to press them together a little bit. Ooh, look, I forgot a conditional over here. Lazy copying, costing people points. By the way, in case I didn't mention this earlier, you have to do the whole truth table to get all the credit on the exam. You can't just be throwing out contingent or equivalent or valid and hope you're going to get points. If it's a 10-point problem and that's all you do when you get that right, that's 1 point out of 10, just so you know. Okay, so that's not T or E. Then the fourth premise is that not H and D. And the conclusion is R or F. Okay, so now let me put my premise lines in here, right? And my conclusion. So you see I have 1, 2, 3, 4 premises and the conclusion, but I have 1, 2, 3, 4, 5, 6 letters. And I have, if you count the operators and the letters, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. So that means the truth table needed to solve this argument to determine whether it's valid or invalid would be 23 columns across and 64 rows down. Don't worry, I won't give you more than one of those on the exam. I'm just kidding. I'll give you 2. So, I could use a truth table to figure this out. I'm not going to, because I'm not doing 64 columns. In an ordinary semester, we would learn rules to determine that would show that this is valid, so I already know it's going to be valid. Sadly, we're not going to get to those, but when you go take your symbolic logic course at the University of Maryland or the University of Maryland, Baltimore, or Towson, or wherever you go, you'll get to learn these rules. So for now, that's going to conclude our video series. This is Professor Dan wishing you good luck, and I'll see you on the interwebs.